Yeah, so you watched the last video, you got your help on the yellow sheet. Domain and range. I've made a few videos about this. I'm gonna keep on trying to hit it. I really need you to think of it as a range of values. So domain relates to the X, the inputs. And domain is usually things like time, or number of people, or things like that. And domain, it has a range of values. You can't just have one X values for a lot of these functions. There's usually not just one option. So, for example, if we are talking about the number of miles that you may drive in an Uber or a Lyft, I prefer Lyft. I drive Lyft every now and then. I'm not going to drive 100 miles with you. I'm not going to Chicago from Milwaukee. You're crazy. So the range of values that I might drive you is, 0 or really 0.1 miles. You can't make a 0-mile ride. And maybe it's 30 miles. So the domain is Chinese finger trapped. I can take you 0.1 miles or greater than 0 miles. I should say just greater than 0. And I can get all the way up to 30 miles, and I can equal 30 miles. So the values will be somewhere in between 0 and 30. Not actually going to be 0 though, so it'll be 0.1. Now the corresponding range is the Y values or the outputs. And in this case, if I'm driving you a certain number of miles in a Lyft, the range would be how much you're going to pay me. There's a minimum charge to pick somebody up, so that may be $3 or $3.50 or whatever it may be, and then there's some type of calculation that happens depending on the time of the day that tells the program how much I'm going to charge per mile. Let's say it works out to $2 a mile. If I pick you up, it's going to cost you at least $3.50. Let's say it's $3.50, and then every mile I drive you is going to be about $2. So you can figure out if you're trying to get a 10-mile ride. Maybe you're going from the south side of Milwaukee somewhere on the north side, or maybe you're going to do like an 8-mile ride downtown to my house. It's more like 7. You figure out how much it might be, so you can plan ahead. So you know that your range would be from $3.50, no less, up to maybe $65 or so. And that's the range. It cannot be any higher than 65, and it cannot be any lower than 350. That is the concept of domain and range. So domain is all your X's, and it can be a range of values, or if it's a discrete function with just points or just a table, it can just be those values. And the range is the same thing. It can be from 0 to infinity. It can be from 10 back to negative infinity. It can go all different ways depending on your function. Real life functions, though, usually don't have too much negative involved. So with that being said, we have our example here. I'm not going to go through all of these on this video. I don't got time for that. But you'll see I set it up. So that is a linear function. It's a line segment. It does not go on forever. So I know my domain and range have bounds. So I set up my dumbbells or my Chinese finger traps. And domain, you notice on the left side, we always go left to right, is an open circle. The concept of open circles is you're never actually going to touch that point, but you'll get really close. A closed circle is it could also be equal to it. So the domain, the lowest value is -6. We're not actually going to touch -6. We're going to be just greater than -6, but we can get down to -6 up to 0, including 0. That's your domain. So over here, I set up my inequalities. So it's going to be x is something compared to -6, and x is something compared to 0. So I already said x has to be greater than -6, because from -6 we're going to the right. -5 is bigger than -6. 0 is bigger than -6. Has more value, so we're going up. We're going greater than. And compared to 0, x can't go greater. It has to go left. We set up our compound inequality, and we'll fill that in, and I'll show you what it looks like in just a second. So I filled in my inequalities. X has to be greater than -6, and x has to be less than or equal to 0. That's just where we can be. So we can't have a value of 1, and we can't have a value of -7. We can't even really have a value. We can't even have a value of -6. Now, what you see here is called a compound inequality. We basically just took the two and put it together. I prefer this method, and we will spend more time on this. So what we're saying is x is greater than -6, and x is less than or equal to 0. Or -6 is less than x, and x is less than or equal to 0. Whichever way you read it, that communicates the exact same thing. Those are equivalent statements. I'll fill out the range for you and then show you. So you can see the range is filled in. The two bookend numbers I'm looking at are 2 and 5. So y must be greater than 2, and y must be less than or equal to 5. I write the same compound inequality. So when you make that verbal, when you talk about it, you just gotta make sure you know how to set it up. I'm gonna do one more of these. So I'll look at this one here, just because it's gonna be slightly different, because you'll notice that it only has 2 points marked. However, a line or a line segment or a curve is just consisting of infinitely many points. So there's points all over the place. So I'm gonna mark the highest point, and I'm gonna mark the lowest point to help me come up with my domain and range. I'm just gonna do this problem and then show you. All right, so a lot of this work, guys, is in the setup. So you'll notice I made those 2 points in purple, and I probably should have put them in yellow to match up with my range colors. That was my mistake. I set up my inequalities, and I went ahead and plugged in the boundaries. So I know that the x coordinates are going from -3 to 4. That's the domain. And I know the range is going from -2 to 2. So now I just got to set up my inequalities. So if you want to pause the video right now and try and do this yourself, it's a good time to do that. Pause the video if you need to do it. I'm going to keep going. So looking at x is at -3, all the possible x values are to the right or greater than. Because it's a closed circle, I know I can touch -3, it's included. On the on the +4, I'm not going to the right anymore, I'm going to the left because it's trapped in between. It's an and. When it's and, it's in between. So I'm gonna be less than 4. And then if I'm looking at the y values, I'm going between 2 closed points, so it's less than or equal to, or greater than or equal to. And I'm greater than or equal to -2. And I'm less than or equal to 2. So I have my domain and range. Sorry, let me fill in my compound so I can show you. And this gives me the picture. It tells me where the graph has to exist. It gives me a lot of information. With just that information, I don't know exactly what the graph looks like, but I can be creative and come up with an idea. And when I get to know what common functions look like, I can make this. I can recreate something like this. So that's what it is. If you need to check the rest of your work, that's on you. I will say for this one, the y value doesn't change. It's a horizontal line, has a slope of 0. So the y will just be equal to whatever. Right, so on the back side, you had a contextual problem. And this is facts, because I guarantee you at some point you'll need a plumber unless you know a plumber. The key words for me was fixed costs and 45 per hour. And that's going to be a y value, because when you're talking about money, it's your output. So the minimum amount you're going to pay this plumber is $80 just for them to show up. And then $45 per hour. You can work, I believe it was 8 hours. So 45 times 8, do the math, and the most you'll pay them is $440. For this one, this is an exponential function. And I knew right away that A and D were not valid, because if you look at the domain, it doesn't go past this -4. So every x value has to be greater than -4. And if you look at the range, it doesn't go into negatives. And this curve right here with that arrow, it's never actually going to touch 0. It'll get infinitely close, but it won't actually be 0. It might as well be 0 in our minds, but it won't be 0. So the range values are everything greater than 0. On the bottom, you have a little challenge. And this just requires you to read and apply some math. So you know how big the domain is, and you know how big the range is. You just have to apply that to the numbers that exist. So that's our first domain and range sheet from last week. If you have any questions, let me know.